physics. Okay.
Yes, sir.
Yes. Let me start. And how are you? Good.
Yes, sir.
Okay, that's good. So, what are you studying in school in physics?
So it's only electricity.
You're studying electricity in school?
Yes, sir.
We have already covered electricity, I think.
Yes.
Yes. Okay.
Yes, sir.
So can you see? I think the book is not loaded yet. Book is loading. Wait. I just check. Just 1 minute. I'll see why book is not loaded. Book.
Okay.
Yeah. So now you will see it. Now it will be visible. Yeah. Can you see the book?
So it's only.
Yeah. So what do we have? We have these are the things we did in the last class about electricity. Okay.
Yes.
And we have done major things, and we had to start electric charge. We have covered all these things. There are a couple of things I will tell you before we move to uh, charge. Okay, so do you remember that in the last class we talked about alternating current and direct current, and after that I shared you a video, right? Have you watched the
Yes,
video?
sir. Yes, sir.
Yes. So, there are two type of current, alternating current, like moving like a wave, and then a direct current, like a line. And
Yes,
after
sir.
that, what we will study after that, like current and volts in circuits. Okay, there are different type of things around you. Like if I talk about what are the things that you see around yourself?
So fridges, television,
What?
phones, so TV,
Okay.
tele-
Okay. What are the things around you that are conductors of electricity? Like a wire, like something made of iron, something made of metal, right?
a fridge.
Yeah, the fridge, if it is metallic, then it can conduct electricity. But if I talk about
Yes.
non like insulators, things which will not conduct electricity, like wood, paper, clothes, they will not conduct electricity, right? So there are two
Yes.
type of things around us. Either they are conductors or they are insulators. Okay?
Yes, sir.
Yes. So if they are conducting electricity, if they allow electricity to pass through them, we will call them as conductors. Okay?
Okay, sir.
If electricity not passes through them, we will call them insulators.
Yes, wait.
Yes. And then can you read this statement? You have to remember this as well.
An electric current is a flow of charge in metal wires. The charge are carried by very small particles called electrons.
Yeah. So the flow of charge is called current. In metal wires, the charge are carried by very small
Elect-
particles called electrons. You know
uh,
about electrons?
yes,
Yes.
sir.
Yes, we will study in detail in the upcoming topic. Okay. So,
Okay.
electrons flow easily through all the metals. They flow easily through all the metals. We therefore describe metals as being good conductors of electricity. Okay. Electrons do not flow easily through plastics. They are called poor conductors of electricity. A poor conductor is known as insulator and is often used in situations where we want to prevent the charge. Like you have seen a plug, right? Like if I show you a plug, casing of a plug, like the body, it is made of plastic. If it is not of plastic, if it is of metal, you will get a
Yes, sir.
shock when you will plug in, right?
Yes, sir.
Yes. So we need insulator there. A very poor conductor is known as insulator, okay? And
Yes.
some electrons are free to move between the in metals. Like if this is a metal, there are some free electrons to move. Okay. And
Yes,
Yes,
this
sir.
sir.
movement is very random. They are moving here and there, like in any direction. But once you apply a current, they will flow in a particular direction. Okay.
Yes,
Yes,
sir.
sir.
Yes, you can see all of them are moving. Most of them are moving in this direction, right? That
Yes,
means
Yes,
sir.
there
sir.
is a voltage, there is a positive charge, and all the electrons are trying to go towards the positive charge. Okay.
Yes,
Yes,
sir.
sir.
Yes. And in insulators, the electrons are very tight. They do not move. That is why they are insulators. Okay.
Yes, sir.
What is the device to measure current?
So it says
So,
ammeter.
ammeter.
Yes, an ammeter is used to measure current in a circuit. It has a very low resistance, so almost no effect on the current. Got it? Like
Yes,
Yes,
sir.
this is a circuit. This is your battery or cell, or you can say anything which is producing electricity. This
Yes,
is
sir.
your bulb. This is your bulb,
That's the ammomet. The
and this is the ammeter. Okay.
yes, sir.
Yes, it is okay. There are two type of connections. One is series and other one is parallel. I will tell you how they work. Okay.
yes, sir.
Yes, sir.
Yes,
So
I
we
will
did
show.
So,
this.
so
So we did this topic
in
on
school.
Monday in school on Monday.
You have done it on like you did it in on Monday in school.
Yes, sir.
Yes, sir.
What are series and parallel connections? Can you show? Can you tell? Can you?
So parallel connections is where we have more than two
Six. Yeah, something like
no.
that.
So we have more than two bulbs. No,
You have more
wait.
than?
So I'll be right back, please, sir.
So the six series is the simplest.
Yeah. See, you can see in this picture here.
Yes, sir.
They are connected one after other. Like, see, this is the one end of the ammeter. This is the other end of the ammeter. So this end is connected to bulb from one side and to the cell or connect like electric producing thing in the other side, right? And they are connected in a series, right? One after
Yes, sir.
other. This is a series connection. But after this, there will be a parallel connection as well that we will see. But before that, you have to know about charge. You have to know about charge. Okay. So
Yes.
yeah, this is the formula for charge. Charge is equal to current times time. Okay.
Yes, sir.
Charge is equal to current multiplied by time. Can you do example number A and example number B? Can you try?
Yes, sir.
Yeah, just try. Yeah, hi. Are you there?
Yes, sir.
Yes. See, can you read question A? Calculate the charge flowing through a wire in 5 seconds. This is time, right?
Yes,
Yes,
sir.
sir.
And current is 3 amperes. So you know what
Yes,
is charge? Charge is current multiplied by time, 5 multiplied by 3, right?
Please, sir.
yes, sir.
Please, sir.
Ha ha.
Please, sir. They said O is columns. Please, sir. What is columns?
Coulomb is the unit. Like, see, how you measure time in seconds, minutes, or hours, how you measure current in amperes, in right? How you measure charge? You measure charge in coulombs. Okay.
Yes,
Okay,
sir.
sir.
Q, they are using Q for charge, and C is the unit of charge. Okay.
Okay, sir.
Like they are using T for time, and S is unit of time. I for current, and A is unit of current. Got it?
Yes, sir.
How many electrons are flowing through the wire in this time? You know, 1 coulomb of charge has these many electrons. 6 into 10 to the power 18 electrons. You have to remember. In chemistry, they will teach you this in chemistry. In 1 coulomb of charge, there are 6 times 10 to the power 18 electrons. Okay?
Yes, sir.
Yes. So 15 coulomb means this is 15 times, right?
Yes, sir.
Yes. So this many electrons will flow through wire in 5 seconds. What?
Yes, sir.
Yes. Now what is this? This is the battery. This is the cell that we use in remotes, right?
Yes, sir.
Yes. See, can you read this part like from here to here quickly?
Mm, yes, sir.
Okay. As a charge flows around the circuit, energy they carry as a charge as a charge flows around the circuit, the energy they carry is transferred by the components they passes through. They passes through. For example, when current passes through a bulb, energy is transferred to the surrounding as heat and light. When the current passes through the speaker as of a radio, most of the energy is transferred as sound. In the external part of a circuit, that is the outside of the cell or battery, the voltage across each component tells us how much energy is transferring. If the voltage across a component is 1 volt, this means that the component is transferring. Please, sir, what is J?
Judas.
Yes. Energy transferred, like energy. How much energy? See, when you turn on the switch, current flows, right?
Yes,
Yes,
sir.
sir.
So when the current is flowing, some energy is also flowing. How to calculate how much energy is flowing? The formula is energy transferred. That is how much charge and how much is the voltage. Got it?
Yes,
Yes,
sir.
sir.
See, once I complete this chapter, you have to write down all the formulas. Okay?
Yes, sir.
Important formulas like one we did here, and then we did a couple of formulas before this as well. Okay? Can you try example 2 and example 3? You have to remember this formula. Okay?
Yes, sir.
Do it.
It's okay.
The voltage is 12 volts, and you have to calculate the electric energy transferred. So energy is like voltage multiplied by current charge. Charge is 50 coulomb and voltage is 12. 50 times 12, that is 600 joules of energy. Okay?
Yes, sir. Yes, sir.
Yes. And now you know what you can also do. I told you how to calculate charge. Do you remember how to calculate charge?
Yes,
We
sir.
calculate charge when we multiply
Current times time.
current times time. So if you have to find current first, you can also write current times time multiplied by voltage to get the energy. Okay?
Yes, sir.
Yes. So total amount of energy transferred during this time. This is current 5 ampere, time that is 5 into 60 because 5 minutes, so 300 seconds, and then voltage 230 volts. When you multiply all of them together, you will get
245.
345,000 joules or 345 kilojoules. Got it?
Yes, sir.
Yes. This is how you can solve problems. And see, I told you a device to measure current. What was name of the device to measure current?
And ammo.
Ammometer.
Ammeter, just ammeter.
Ammet
Okay, now the device to measure voltage is called,
Volt.
Voltmeter.
yes, a voltmeter used to measure the voltage. But it is not connected in series. It is connected in parallel. You can see. If it is in series, it will be like this. One end connected to the one end. See, one end connected to one end, right?
Yes, sir.
And the other end connected to the battery. But if it is in parallel, both the ends are connected to the ends of the bulb, right?
Yes, sir.
Yes. This is called a parallel connection. Okay.
Yes, sir.
Yes. Electrical circuits. What are electrical circuits? Electrical circuits contain cells or batteries. They contain a switch, they contain a bulb, or they can contain any device that you see in your house. These are all called electrical circuits, right?
Yes, sir.
Yes. And then there are some key points. When you are drawing a diagram, whenever you will make a switch, if it is open, if it is not working, it will be like this. If it is a closed, it will be like this. If you are making a cell, it is like this, a single cell. If there are so many cells, they will form a battery. This is a battery. Then this is a diode. Do you know about a diode?
No, sir.
Do you know about the bulb, light bulb? It is called light emitting diode, right? There are so many small bulbs called diodes. They emit light. Okay, you will study in detail in the coming classes about this diode thing. But what is a resistor? To provide the resistance, to provide a resistance to flow of current, that is called
Yes.
resistor. Resistance. If you can control the resistance power, that will be a variable resistor. This is a bulb. I told you about a fuse, right?
Yes,
Yes,
sir.
sir.
Then voltmeter I told you, ammeter I told
Yes.
you. This is a
Yes, sir.
thermistor. Okay, so this you will use in the coming classes in detail. And this is light dependent resistor. If light will flow on it, its resistance will increase. Okay, again a resistor kind of. I'll tell you the important ones. So these are the important ones, these four, and then these are important, and these two are important. Okay.
Okay,
Yes,
sir.
sir.
Please, can we draw it?
After the class, you can draw. Okay, don't. It will take a lot of time. You can remember. Okay.
Yes, sir.
Yes. And is it on? Yeah. So now see, have you seen some devices in which there are small bulbs which show they are on or not?
Yes,
Yes, sir.
sir.
Yes. So they put small bulbs in circuit to show that if circuit is turned on, so that we cannot touch it and we can prevent electric shock. Okay. And then there are two type of circuits. I told you about them, series and parallel. Okay.
Yes, sir.
Yeah. A is a series circuit or a parallel circuit?
So
A
series
series
circuit.
circuit, right?
Yes, sir.
And then B is in a parallel. Okay, so can you? There are two type of main electric circuits. The circuits where there are no branches. See, there are no branches here, or there are no junctions. There is only one path, and current can follow. See, there is only one path, right?
Yes,
Yes,
sir.
sir.
Yes. These simple single loops circuits are called series circuits. Single loop series circuit. Now here, branching is see, you can see this is a junction, right? This is a junction. Junction means where there are two or more ways, right?
Yes, sir.
Yes. So junction. Current can flow are called parallel circuits. When there are junctions and when there are many paths of current. See, current is flowing like this, but it is also flowing at the same time like this, and it is also flowing at the same time like this. There are more paths, more than one paths for current. So this circuit is in parallel. Okay.
Yes,
Yes,
sir.
sir.
Yes. So they behave differently. Okay. Can you read from here? Can you read a bit from here?
Yes, sir. Series circuit and parallel circuit
Behave.
behave differently. This makes them useful in different situations. in a series circuit contains bulb. One switch one switch placed on way
Anyway.
anywhere in the circuit can turn all the bulbs on and off. If any of the bulbs break, it causes a gap in the circuit and all of the other bulbs will stop working. The energy supplied by the cells is shared between all the bulbs, so the more bulbs you add to a series circuit, the less brighter they all become.
Got it?
Yes, sir.
So if you add one more bulb in the circuit in series, it will, like, its intensity will decrease. Okay.
Yes, sir.
But in parallel, any number of bulbs you can add, they will glow same with same light. Okay.
Yes,
Yes,
sir.
sir.
And they are all in series here. See, they are all in series. If any of the bulb will break, the circuit will break, right?
Yes, sir.
Because the current will not flow from here to the upcoming bulbs. So we can say that no, no current, right?
Yes, sir.
But here in B, if this bulb breaks, there is no effect because still the current is going like this to the other bulbs, right?
Yes, sir.
Yes. So one is called series connection, one is called parallel connection. Okay.
Yes,
Yes,
sir.
sir.
Yeah. But and after that, in a parallel circuit containing bulbs, can you read this also? This is also a bit important.
Series circuits and parallel circuits behave differently. This makes them useful in different situations. In a series circuit contain in a series circuit containing bulbs, one switch placed anywhere in the circuit can turn all. Please, I'm just reading this one.
What?
Okay, sir, I've seen.
Wait. Yeah. Can you see?
Yes, sir.
Switches can be placed in
Yes, sir.
different parts.
In a parallel circuit containing bulbs, switches can be placed in different parts of the circuit to switch each bulb on and off individually or all together. In one bulb, if one bulb breaks, only the bulbs on the same branches of the circuit will be affected. If branches of the circuit receive the same voltage, so if more bulbs are added to a circuit in parallel, they are all keeping the same brightness.
See, um, if the devices are in parallel, they can have different switches. Okay, and if one bulb breaks, only the bulb on the same branch of the circuit will be affected. This is about parallel. Okay.
Yes, sir.
Yes. Can you see? These are in parallel, right? These are in
Yes.
series. So the current is getting divided on all of them, and these are in parallel. So you can just see, the size of current in electric circuit depends on the voltage supplied to it, and the number and type of other components in the circuit. If a second identical cell is added in the series, the voltage will double and current will also double. See, this is only one cell, right?
Yes, sir.
So 2 ampere current through all of the devices, right?
Yes, sir.
But here two cells. So current will double 4 ampere, 4 ampere, 4 ampere, right?
Yes, sir.
Yeah. And here in parallel circuit, the current will not be same in different part of the circuit. The type of component in each different part will affect. See, how much current? 0.6 ampere, right?
Yes, sir.
Yes. Now what will happen? 0.6, 0.4 current going through this, right?
Yes, sir.
Because not even distribution. And after that, 0.2 current only going through this. Okay.
Yes, sir.
Because it is not different in parallel circuit, it is different. Got it?
Yes, sir.
Yes. And after that, we have the next topic called electrical resistance. Okay.
Yes, sir.
Yes. What are you going to study about? Yeah. So, all components in circuit offer some resistance to the flow of charge. What do you know the meaning of the word resistance?
So like reducing the voltage, the power of the electricity.
So, to me, resistance means that if, example, let me say a very hot pot is on fire and you touch the pot, you can resist power. It's the same thing with electricity.
So like you're balancing the electricity,
Yes, sir.
the current.
Okay. Yeah, somehow you are right, somewhat. Like, see, all the components in electric current, like in the circuit, offer some resistance. Some,
Yes, sir.
yes, yes, Nakoma, yes.
So the battery is low. We want to continue on the phone.
What? Can you repeat?
The battery is low
The laptop
of the laptop. The battery of the
and
laptop
there's
is
no
low,
electricity.
and there's no electricity.
You can join from phone.
Yes, sir.
Yes,
So we
sir.
want to join the phone.
Wash your face.
Join from your phone, okay?
Yes,
Yes,
sir.
sir. So we joined.
Have you joined? Okay, you can leave from the laptop also. No, no problem.